Hello everyone, my name is Mehrab and I'm a computer science PhD student at Georgia Tech. My talk is going to focus on how we can use passive sensors for measuring self-esteem. I will present the first half of the talk and then my co-primary author Koustuv Saha will present the later half of the presentation. So what is self-esteem? Self-esteem corresponds to someone evaluating themselves in the form of how much they like or dislike themselves. Understanding self-esteem can foster adopting preemptive steps to facilitate the psychological and cognitive needs of individuals. Individuals with damaged and lower self-esteem are at a greater risk of psychosocial distress and may be vulnerable to the demanding circumstances of day-to-day life. Therefore, measuring self-esteem is extremely important in many cases. There are multiple ways to measure it. The traditional form for measuring self-esteem relies on a survey, which asks experiences of individuals about various things over a long period of time, and such practice generates recall bias for the participants since it is hard for individuals to reflect on experiences that happened earlier compared to the time when they were responding to surveys. Now, how is our approach different? Almost all of us carry a smartphone with us. Some of us use wearables such as smartwatches, and these smart devices are equipped with hardware sensors such as accelerometer, microphone, gyroscope, among other things. These sensors can be used for collecting large-scale, continuous, rich and dense longitudinal data that can be used to infer an individual's physical and social activities. Hence, based on the promise of passive sensing, in this project we investigated this question. Can we automatically and scalably predict self-esteem using passive sensing modalities available on commodity devices? In order to answer our questions, we worked with Campus Life dataset. Campus Life dataset encompasses passive sensing data and survey data from Georgia Tech students and their well-being during a period of 2016. The Campus Life project recruited over 51 Georgia Tech students. 60% of the participants were males and 40% were females. Two modalities of passive sensing were used in this project. These include smartphone sensors and social media. Passive sensing data from smartphones contain various information such as individuals' inferred physical activity, inferred conversation, and communication frequency of text messages and phone calls, among other things. Validated surveys serve as ground truth in the study. My co-primary author, Koustuv, will present the next part of the presentation. Thank you.
Hey, I'm Koustuv, and I'm going to walk you through the methods and results of our study. So as we aim to predict self-esteem using passive sensors, we adopt a regression-based approach. Here, the ground truth data comes from EMA-based surveys of self-esteem, measuring performance, social, and appearance-based self-esteem. And the features or the independent variables come from passive sensing data, including frequencies of calls, texts, conversations, as well as physical activity-based features. We adopt leave one out cross-validation approach to validate our predictions. And among the different prediction algorithms that we built to model self-esteem, the gradient boosted regressor performed the best across all three kinds of self-esteem. It shows a low symmetric mean absolute percentage error, or SMAP, of around 7%. And we also extracted the top features in our predictive models using ANOVA and K-based univariate scoring methodologies. We note the strong association of social features, which aligns with prior literature or that low self-esteem often associates with isolation and lack of communication. Now let me reiterate the takeaways of our study. We showed the feasibility to measure self-esteem using passive sensing data, and our study motivates approaches to proactively understand well-being in situated communities. With that, we would like to conclude our presentation, and please feel free to reach out to us if you have any questions. Thanks a lot.